All right. Thanks, everybody, for coming to our meetup tonight. You are the committed core who watch technical talks from 9 a.m. to 6 p.m. and then grab a beer and watch more technical talks. I hope all of you will be joining us at Jones after this, and we'll get to that in a little bit. The format of this meetup will be a 15-minute talk by Patrick Wendell, and then 45 minutes or so of Q&A with a panel of Spark committers. It's my pleasure for the second time today to introduce Patrick. If you don't remember from this morning, Patrick is a co-founder at Databricks, one of the leads in the Spark project. He was a founding committer on Spark, and he leads the Spark team at Databricks. And tonight he'll be giving a talk, which I believe is an abbreviated version of the original talk he was planning, Spark 1.4 Deep Dive, and he'll say more about that.
Thank you, Andy. Thanks, everyone, for being here. I'm just curious to do a quick show of hands. I'm curious how many people were not actually at Spark Summit today, but are just joining here for this evening meetup. How many people are, just to keep them high? All right, that's maybe 20%, great. And then of people who were, let me figure out how to phrase this, because I gave a keynote, but it was very early this morning, so I'm wondering how many people actually saw my talk this morning at the Spark Summit? That's like 50%, okay. So this talk will be somewhat similar to the talk I gave this morning. I'll keep it quick, but I'll extend and expand beyond that a little bit. What I originally titled this talk was Spark 1.4 Deep Dive. Since then, we were able to assemble a panel of committers on almost every component of Spark. So I am turning my deep dive into a shallow swim. And I will just use 10 or 15 minutes to tell you about some new features in this release, but I will let the majority of the time be devoted to a kind of panel, Ask Us Anything, with a bunch of people who are working on Spark and have probably way more interesting stuff to say than I do. So I think we have like around five or so committers who are here that cover many of the components of Spark, and most of this will be devoted to you asking them questions as the audience. We'll see how long that goes for. When that's done, we'll all go and party at the after party from this event. So I'm going to talk a little bit about the Spark 1.4 release as a way to kick off questions and fill you in a little bit about some of the current stuff that's going on in Spark. And before I do that, I'm going to see if I can get a clicker here so that I don't have to stand behind the podium. Perfect. OK, so this release, before I talk about it, I'm going to give a couple of a little bit of background on how we do releases in Spark in general. So the way Spark development works is that we have this master branch. This is all maintained in Git. And that branch kind of continues forward as we add new features and patches. And then at some point, we fork off what's called a release branch, which means it's going to become the basis of a release. And we'll actually continue to add fixes and other minor things on that branch as development goes on in master. And eventually, we decide, OK, this thing is ready. And we tag one of the commits as a release. So I'm telling you this because it's actually helpful as a user of Spark, someone who may consider doing some proof of concepts, to understand how versioning works in Spark. But when I say Spark 1.4.0, I mean this is the first sort of release on the branch 1.4 maintenance branch. And we may do future releases on that branch, like 1.4.1, which just contain more fixes. And the implication here is that if you're just getting started with Spark, doing like a proof of concept and something where you're willing to use maybe a slightly newer version that gets all the features, we recommend that you either download the most recent release, or even better, run off the head commit of a release branch. You'll get kind of 1.4.0, but then you'll also get a lot of new fixes that we've added in the meantime. We just haven't actually cut a formal release. So I just wanted to give that context on how to think about Spark releases. A little bit about this release. So it was released last week, so you already have access to this. And that's kind of exciting, because I usually end up giving these talks before the release actually happens. And this time, you can actually go. I'm just going to start a little timer here. You can go and download Spark 1.4 right now if you want to on your laptop. So that's kind of cool. We had more than 200 developers. This is almost double the number we had last year. I didn't even finish this count. It actually gets higher than this. And 1,000 commits and about 3 months of development. We do releases every 3 months, so a release of this size happens every 3 months. Now, the headline feature in this release is that for the first time since around 2013, I mentioned this morning, maybe slightly repetitive for some people, we added support for a new programming language. Our last one was Python, which has become a very popular way to use Spark, and now we're adding support for the R language. I'll just say a little bit about R. I'm pointing out an upward trend, and trend analysis is a kind of example of something that people might do inside of R. But it's a language that is very popular amongst statisticians, data scientists, mathematicians, this community, for doing super fast forensic analysis on data. And it has this really nice abstraction called a data frame that makes working with data sets and summarizing them and modeling them very convenient. And as a result, the Spark R API is actually based on our data frame API in Spark, which itself was largely inspired by Pandas, R, and these other scientific mathematical libraries. The nice thing about Spark R is that the R runtime that exists today has trouble with big data. It doesn't actually even have multiple core support, let alone support for scaling out to many machines. So Spark R users can stay in the R runtime and get kind of all of the benefits of Spark. And that means scaling to many machines, scaling to hundreds or thousands of machines. And they get the benefit of all of the engineering we've done around optimizing big data workloads. And that means optimizing things like data placement, partitioning, pushing sort of predicates and other things into storage systems to avoid having to do lots of I/O, which becomes a big bottleneck for large scale. So basically, you get all the benefits of the Spark runtime as an R user. And what's even cooler is that because we've decided to do this through Spark's data frame API, there is a great performance parity with other language APIs in Spark. So our users don't need to sacrifice anything in terms of performance compared to someone using the Scala or Python API, which is exactly what this graph shows. It just gives you 3 different examples of the same program in different languages. And within a very small margin, they all have identical performance. The last thing I'll point out is that in Spark, we focus a lot in the last few releases on a really nice data source integration API. Many people use Spark to take data from multiple sources and blend it together as part of an ETL pipeline at the beginning of a longer job. And as a Spark R user, you get access to all of these features. You can just point Spark at JSON data from data sources like MySQL, Postgres, and RDBMS systems to all the way to Hive tables in the Hadoop ecosystem. And this list extends. There's many third-party data sources as well. And you just have to go to sparkpackages.org, and you can see a much longer list of these. The next major thing in Spark 1.4 is the ML pipelines feature, which is something that there's been pieces of in previous releases, now graduates as a first-class supported API in Spark. And we had previously tagged it as alpha, which means we were still getting feedback and might make minor modifications to the API. To say a word or two on ML pipelines, this is really about going from that exploration that I talked about in a language like R that may involve a data scientist kind of interactively exploring data to productionizing that process into a regularly running job that may build models continuously and train and test data. So this is a very short example of a machine learning pipeline. I won't go into too much detail, but this pipeline takes some incoming data, it tokenizes it by splitting up records into individual words. It does a hashing transformation that kind of reduces the state space over possible words. And then it does a logistic regression to kind of train a model that will learn how to predict labels given this a new input that it hasn't seen before. And this becomes a reusable component that you can use as part of a broader pipeline. I'm also showing some code for then taking that pipeline, training some data that's in a Spark data frame, could have been JSON or Hive or whatever, and then testing it on some new data. So I'm not going to go in detail on all the lines of code here, but one thing I did want to point out is that this is Python pseudocode. And one of the major features that's part of graduation here for the ML Pipelines API is that the Python support has been brought almost up to parity with Java and Scala. A couple of other things that go into this becoming kind of a graduated API. One is that, as I said before, it's stable. We won't change anything. Another is that we've actually opened up APIs in here for third parties to add pipeline components. So if you as a library author want to kind of write a pipeline component, you can publish it in a Spark's package repository and other people can use it. And we've also added as part of this release a bunch of kind of utility feature engineering or feature transformers that are useful for feature engineering, which you see on the left, and some new algorithms inside of the pipelines API, which you can see on the right. And if you have detailed questions about this, Joseph Bradley, our committer on MLlib, who will be in the Q&A, will be happy to answer them. So another thing that I didn't get to talk about this morning, which was a major theme of this release, was adding much better kind of instrumentation and diagnosis of what's happening inside of a Spark program. This is just a common piece of feedback we've gotten from now the production users of Spark who have said, look, Spark is amazing. I want to learn more about what's influencing performance. In streaming, I want to learn about how is the stability of the system? Am I processing data more quickly than I'm ingesting it? And these types of things. So kind of all across Spark in this release, you'll see a lot of JavaScript, candidly. We've developed a new skill set as a project. A lot of visualization around instrumentation inside of a Spark job. And this is a pretty cool feature. I think we'll be enhancing it in future versions to cover new things. But in this release, you see a lot of this across the whole project. Also, one thing that's not mentioned in this slide is we also added new UI components to things in Spark that previously didn't even have a UI. Like our SQL JDBC server now has its own UI, which can print out query plans and show you SQL queries as they're entered, which is kind of cool. So in the Spark, speaking of Spark SQL, in the Spark SQL and DataFrame part of the project, for those who went to Michael's talk today, you'll know that Spark SQL and DataFrames are really intrinsically linked. They both use the same optimizer underneath, but they have slightly different higher level APIs. Spark SQL is a SQL API and DataFrames is a sort of R DataFrame style API. What have we done here? Well, actually a lot, but a few things that bear mentioning. Our data source API, which I mentioned before, is the way that we have kind of pluggable data sources in Spark. This added support for ORC file. That's a very popular file format that has a lot of nice features like columnar storage. And we also added a little bit of an internal detail, but partitioning, which means sort of physically laying data out in a way that lets you skip reading a lot of the data. It's a very common thing to do in production kind of Hive warehouses. That has added first-class support in the data source API. So as we add more sources, they'll be able to support partitioning without a lot of extra work. And what it really means for you as an end user is that you'll start to see more and more data sources here that can support kind of partition tables, and they'll come much faster. We don't have to reinvent the wheel. We also added a bunch of analytic functions. If you're interested in this, I'd recommend checking out the Databricks blog. We have a nice blog post on this. But the biggest one is window functions. It's a really popular sort of SQL feature for doing lots of things. Lots of things are easy to express in window functions, time series analysis, and others. And we added that in the SQL API and also in DataFrames. Alongside that, we've added kind of a lot of statistics utilities, ways of dealing with missing data. And this is really inspired by the single node data frame implementations in things like pandas. So we don't really consider this novel, except that it's able to work on very large data with a lot of optimizations. And so that's you get a familiar API, but can scale to much larger data sets. And the last kind of notable feature in the Spark SQL area is the ability to do sort merge joins. So for large joins where memory pressure can be an issue, this should be much more efficient. And I believe this was a community feature. I'm not sure which company contributed this? But contributed by Intel. Thanks, Michael. I thought of a couple other things to mention around the project, and I'm really almost done, so we'll get to the fun part soon. But in Python, we added Python 3 support. For those who aren't following how Python versioning works, there's a Python 3 is actually not fully source compatible with Python 2. So we did some extra work to make us compatible with Python 3. And that's something that a lot of developers have been asking for who have a Python 3 based deployment inside of their company. And so now we support that. And also in the Python API, we have a streaming component called the Direct Kafka API, which is how actually most people interact with Kafka inside of Spark. And that was ported to Python and may actually see some more enhancements in this coming release, but that has at least had an initial port to Python, so it's available for Python users. A couple other things here. The Spark shuffles have gotten faster as we've done some changes to improve memory pressure. This is going to be a much larger improvement, most likely, in Spark 1.5 based on the work in the Tungsten initiative, but pieces of it came in 1.4, and several users we worked with saw fairly significant, maybe 20 to 50% in performance improvements just from this feature, which is really nice. And Spark also adds a REST API for kind of querying information about the ongoing state of the Spark program, and that's really useful for people writing third-party monitoring integrations and other stuff like that. Around deployment, a couple things. So one is Spark on Yarn continues to add a lot of new features. Yarn is now supported in Spark's EC2 scripts, where you can launch a Spark cluster on EC2 with Yarn. And for long-running applications like Spark Streaming, that now works with Kerberos security in the Hadoop ecosystem, which is really nice because many people want to run secured streaming applications. On the Mesos side, we added support for cluster mode. This is like one of the deployment modes in Spark. That previously wasn't supported on Mesos, and thanks a lot to TypeSafe and Mesosphere who collaborated on this. Also support for launching Spark inside of a Docker image, which is a sort of more attractive way to deploy Spark than the default way in Mesos. Is the mic still? Yeah, there we go. That gave you a lot of information about Spark 1.4. It was intentionally structured as kind of a laundry list because I want to tee up questions for the panel of committers. But if you'd like to learn more about Spark 1.4, a couple things. One is we had a Databricks blog post that covers some themes in this release. Another is that Spark has upstream release notes. And the last one is that this guy, who I actually don't even really know this guy, but he wrote like fantastic overview of Spark 1.4, and I felt like I had to put it up here on this slide. It's like several people came and said, hey man, these are better than the release notes that you write. So I felt like once I'd heard that like 3 or 4 times, I had to put him on the slide. So this guy wrote a really nice summary of Spark 1.4, and if you'd like to kind of get more details on what's in the release, check this out. So I think with that, I will maybe pass the emceeing of this over to Michael. Andy, do we need to set something up before we do that, or? They're still bringing them? So would I just stall for 10 minutes? Okay, so I think now, while this is going on, they're going to bring their own chairs. Okay, so now, so first of all, let me just say thank you very much, and this was the end of my talk. Thank you.
All right. Okay. All right. I've dispatched all the committers to carry a chair to the front of the room.
So maybe I can introduce Michael while you guys are doing this. So now I'm going to hand over the emceeing of this activity to Michael Armbrust, who's currently pulling up a chair. Michael is the lead on the Spark SQL project and wrote almost all the initial code for Spark SQL. And he is heavily involved in many parts of Spark. So please join me in welcoming Michael Armbrust.
Thanks, Patrick. So this is going to be pretty free-form Q&A style. So let's get everyone all set up and everything. Just give me 1 second.
So we're actually, if you have a question for the Q&A session, which I hope many of you do, we're going to make a line for asking questions, and since we only have a limited number of handheld microphones to do this with. So if you can line up in this aisle over here, so that we're not blocking the camera, which will capture the question, the answerers. So if you have a question, line up in this aisle over here, and we'll give you a handheld microphone to pass down the line. Otherwise, I'm sure we can come up with some creative questions on our own to ask each other.
Oh, yeah, OK. Let's start with that. So I'm Michael, and I hand it off to you.
My name is Yin Huai. I mainly work on Spark SQL.
Hello everyone, my name is Cheng Lian, and same as Yin Huai, I also work on Spark SQL. Thanks.
My name is Sandy. I'm from Cloudera. I work mostly on Spark Yarn stuff and just a bunch of smattering of different things.
Hi, my name is TD. I mostly work on Spark streaming stuff.
Hi, my name is Josh Rosen, and I work on Spark Core.
Hi, I'm Andrew. I work on Core, and I know a little bit about Yarn and Messes.
Hi, I'm Shivram. I'm a PhD student in the AMP Lab. I work on Spark R and some parts of Core, I guess.
Hi, I'm Joseph with Databricks, and I primarily work on MLlib.
And I'll remind all the committers, you should eat your mic and speak loudly. Joseph did a really good job. So other people didn't. Okay, so without further ado, let's start with our first question.
Okay, question about Spark R. Question is, what happens if I have a bunch of R code and I try to run it in Spark, but I haven't called any Spark APIs or anything like that? What will really happen? And like, what changes do I need to make to actually be able to process across the cluster?
Yeah.
Data frame across.
Great question. So the first part, to answer the first part, nothing different will happen. Your R code will just run as it would on your machine. From the user's perspective, Spark R is like a library that you can include at the top of your R program, similar to how you might include another library for reading stuff from different files, or a JDBC library to read from like a JDBC database, etc. So right now in the 1.4 release, we are focusing on these data frames. So the way you would use Spark R is you'd include the library at the top, and we have these functions to read in data from different sources, like CSV, JSON, Parquet files, or Hive tables, etc. And once you have that, then you can use the data frame API to access and process data, etc.
So just one quick follow-up. To get the benefits of a delayed evaluation, I just have to call a series of Spark API calls. It's just my R code isn't going to be delayed or anything like that.
Exactly, yeah. So all of the operations you do on the data frame will undergo delayed evaluation. And at the end, if you're doing a collect, a head, or something like that to see the first few rows of your data frame, then they get executed. Exactly.
Awesome. Okay.
First of all, thanks for adding window functions to Spark SQL. Just had a follow-up.
This guy right here gets all the credit.
Just had a follow-up to that. Is there plans to add pivot functionality like SQL Server has to transpose data back and forth between rows and columns?
That's a good question. Do you know if HiveQL supports that?
There's a Jira out there, but nobody's
Okay, but
worked
not
on
yet.
it.
So what I could say is that's not on our immediate roadmap. That does sound very useful. It would be even easier to add as a data frame operation because you wouldn't have to mess with the Hive parser, which sounds painful. So it's not on our immediate roadmap, but that sounds so useful. Pull requests are accepted.
Okay, great. Thanks.
I saw in one of the talks today that MLlib now supports PMML exporting of trained algorithms. My question is there something, it's a specific question. Can I evaluate that PMML using open scoring, or how is it, how would we go about doing that?
Right, so as far as adding PMML support, there is export for certain models. There is not import currently, primarily because there wasn't, to our knowledge, friendly license library, which we could use out there. And import is significantly more challenging because PMML is a very, potentially complex expressive language. That said, there are open source consumers of PMML which you can use, just not under, Apache 2, but maybe for your own use. Yeah.
My question is about stateful stream processing with Spark streaming. And there is a little bit of a challenge there when I check pointing and I have some state, and then time comes to for me to push new release, And unless I have complete binary compatibility of my data structures, I have to basically lose the state and start over. So is there any plans to provide ways to kind of migrate and handle the releases with the state in Spark Streaming?
Great question. So basically the problem is that the Spark Streaming's checkpointing, etc., all the fault tolerance mechanism that doesn't quite support cross Spark version or cross binary application binary. So the moment your dstream operations change, you cannot read back from the checkpoint. So yes, that is something we are aware of, and that's definitely in my wish list of medium-term things that I want to fix. Sometime soon, in next maybe 6 months, that would something we'd definitely like to look at and fix it. So.
And my question is about Spark ML. Do you have any plan to merge the Spark ML lib and the Spark ML? I'm a contributor about Spark. As you know, it is annoyed to develop Spark ML lib and Spark ML.
Right. As far as the relation between MLlib, the original API, and Spark ML, the sort of newer pipelines API, I agree it has been somewhat of an awkward balance where MLlib is sort of still the standard API. Spark ML, of course, only just came out of alpha. As far as like what will happen in the future, I do believe that Spark ML, the pipelines API, will support all of the MLlib algorithms, and I hope that it will be a more useful API for users. As far as the underlying implementations, yeah, it's nice that they can share, but for APIs, I mean, I would still say that MLlib is sort of like the most complete API. I think that they will reach parity in the future. And I think it will rely a lot on user feedback in terms of whether pipelines is basically sufficient to handle use cases.
Hi, I have two related questions about HiveQL implementation in Spark and DataFrames. So I'm interested in how HiveQL is implemented, and the reason is because, for example, for very simple things like histogram, we observe very bad performance on doing a SQL histogram versus converting the data frame directly into the RDD and doing histogram on the RDD. Even though the total CPU time of the RDD histogram is larger, it scales better with a number of cores, while the HiveQL one doesn't scale almost at all.
Okay, I can take that question. So basically, so the way we use Hive in a couple of different ways. We use the HiveQL parser, but really that's it. We get the AST from the parser and we convert it into a Spark SQL plan. When you're talking about functions like histograms, we actually use the Hive UDF for histogram, unless Spark SQL has its own native implementation. So what that means is there's a lot of expectations that those UDFs have about what the input types will be, and we need to do conversions, which is probably where the performance problems are coming from. So what I can say is with DataFrames and with Spark 1.4 and with Project Tungsten, one of the things we're focusing on doing is implementing natively all of the UDFs that Hive has, so we no longer have to rely on their implementations. So hopefully that will go away in the future.
Hi, so first of all, thanks for all the great work you've been doing, guys. Really appreciate it. So my question is in regards to DataFrames or Spark SQL. Basically, what are the general recommendations for using, storing the data on S3 and then reading it back with Spark and not wanting to read first, all the rows, so something like partition pruning, and second of all, not reading all the columns. So basically, what would be like storing Parquet files on S3, and then the second question is, does anything change if we start caching this in memory?
Okay, I guess I can take that one too, although I'll give some credit to Chung, who actually implemented the awesome partitioning support that we now have for Parquet. So yeah, I mean, that you're pretty. I think that's the recommendations you kind of were hinting at sound like a good architecture to me. You want to definitely use partitioning so that we can skip over things. Another trick you can do with Parquet in particular, this isn't on by default in Spark 1.4, but we're turning it on in Spark 1.5, predicate pushdown. Yeah, so in Spark 1.5, it will be on by default, is predicate pushdown. So in addition to the partitioning that you have, you can also sort the data within any given partition by some other column. And Parquet will keep statistics about the min-max values in any given row group, and then we'll skip those row groups. So there's a couple of different levels where we can use this metadata to skip reading data. So partitioned Parquet stored on S3 is definitely a good recommendation.
Can we use this in Spark 1.3.1 as well, or?
So in Spark 1.3.1, you can read partition data that has already been created, but we will not automatically write out partition data for you unless you do it through Hive. So you have to go through like the Hive QL interface to do it.
Okay, and in Spark 1.4.0?
In Spark 1.4.0, the unified input-output API that I talked about in my talk today supports partitioning for any data source that is based on the Hadoop file system. So today this means Parquet and ORC. In the future, it will also include Avro and JSON and really any file format that's stored on HDFS.
Hey guys, got 2 questions for you. First question, pretty much everyone I talk to from AmpLab and Databricks will say, hey, if you have a question you want to follow up on, post it to the Apache Spark user list, right? So I'll post the question up. I'll check 2 days later, 2 views, no responses. 3 days later, 5 views, no responses. What are some ways that I can make more effective responses, more effective posts so that they get responded to? And second question is Mesos versus Yarn. What should I be looking at when comparing the two?
Let's start with the first question. Does anybody have some advice they would like to give?
Oh, so a few different suggestions. There's a hashtag for Spark on Stack Overflow that's quite active. So for sort of more user-focused questions, you might try posting there and get a kind of fast response. Just a general guideline when posting stuff to the mailing lists, it's very helpful if you include the Spark version that you're using, just as a general guideline. On a Stack Overflow, Spark, I think we've actually taken over the Spark tag. And then there's Apache-Spark and a few other synonyms.
There's also Spark SQL.
Yeah. I think there's a Spark streaming. Yeah. Anybody else have suggestions?
So this may apply to just for streaming, but I think it applies to all of Spark as well. Like it really helps if you can, if people just doesn't say, okay, it does not work, and people just have to ask the obvious question that, okay, what is the error? Can you give a stack trace? Can you give the error statement, etc.? So that, I think that will go a long way in actually helping us out to get started off rather than thinking, what do I do with this question? So I think that applies to a lot of, I think pretty much all components of Spark.
Yeah, so I'm going to agree with TD and Josh. Spark version, any logs, and then I think the biggest thing is if you can give us a minimal reproduction of the problem. I know that's a lot more work, but I am so much more likely to look at it, file a JIRA, figure out what's wrong, if I can cause the problem to happen on my machine. So you got to get rid of your data set and all the specifics of it and figure out what is actually causing the problem, which is not always trivial, but you're much more likely to get a response in that case. And then,
yeah, I would like to add a few for Spark SQL. So for big data problems, it's kind of hard to reproduce because of all kinds of environmental factors. So take Spark SQL as an example. We really would like people who ask you questions to attach, for example, query plans and your queries and your data schema, and even better if you can provide example data and maybe a driver log, executor log, basically everything you can give if they are not a credential. If they are not, must be kept as a secret. Sorry, I'm not a native English speaker, so please.
Yeah, so print schema, explain, run those things and give us the output. Okay, and then there was also a question about Mesos versus Yarn. I would say, personally, as a Spark committer, I don't care which one you use. In fact, it's very important for me for both of them to work well. There are minor differences in terms of what functionality is available at any given time. I would say, for example, I think we support dynamic allocation of resources on Yarn, but not Mesos. Only currently. But exactly, only currently. We want to add that support to Mesos as well. So I think it's more about your ecosystem at your company or whatever that should help you make that decision.
Hi, so I haven't used Spark until the recent 2 weeks, and I have a question. This tool is very new to me, and I'm very excited about Spark, and I have a question about logistic regression in LLib. And then I was wondering, like, do you or will you have functionality to update the logistic model with fresh data?
Right. Yeah, if you look at, I guess there would be a couple possible ways. First, if you do have an actual streaming setting, there is streaming support. And if, however, it's just like you've trained a model once and now you have a one-off like new data set, then if I recall correctly, I believe you can initialize with initial weights and intercept, and that would basically let you start from where you were.
Okay, cool. So I can just initialize the weight and then use new data to train.
Right, right.
Awesome, thanks.
Hi, my question is on data frames. Now that data frames have replaced schema RDDs, let's say I have a job which was written for version 1.2, which relied on schema RDDs. Do I have to do something for it to be compatible with 1.4?
There is a list of things in the programming guide that you need to do.
Okay.
that
so
I wrote.
Okay.
So yes, check the programming guide. And if something's missing, submit a pull request to add it to the programming guide.
Okay, my question probably is a little old and be asked for many times. Maybe we can get some new answers today. What do you think is the most advantages of the Scala language over the Java language that makes you think it's better to implement Spark in Scala instead of Java? That what is people doing in that Hadoop ecosystem? Thanks.
I think that I am the Scala fanboy of this crowd. So I guess this one goes to me. So you should definitely check out my talk from Scala Days last year, in particular for the Catalyst optimizer. Like pattern matching when you're manipulating trees of operators is stupidly good. It's so beautiful. It looks really nice. Functional programming in general I find a little bit easier, but that's obviously purely a taste thing. And I will say that we are actually, the parts that make sense, we write in Java. When we have an API and we want to make sure that API is going to work in Java, we do it. We're very committed to Spark users being able to use Java, even if, as a project, we have a preference for writing in Scala. And maybe I'm speaking for people unfairly there.
I'll just add, I hadn't touched Scala at all in my life when I started contributing to Spark, and I would say it's one of the better things that's happened to me. I was mostly using Java before. I mean, I think the central thing, right, is that the initial Spark API is mimicking the Scala collections API. So to do that in Java would have been pretty weird because it's a set of Scala collections. There isn't really a Java equivalent that mimics that. It's also just nicer to use.
Okay, thanks.
Hello. Sorry. I use MLlib, and so pipeline API is so cool, but I think testing code is not good because each case context start and shut down, so maybe very too slow. Because, do you have any plan improve testing code for data pipeline API?
I see. So let me make sure I understood the question. It was about the actual tests, as in like unit tests, or as in like
unit tests. We write custom transformer. So
I see. Right. So I mean, as far and so the goal is to test your custom
yeah.
transformers, for example. Right. So there have been, I mean, up until now, it's been alpha. So most of the transformers I've known about have been written by, MLlib contributors. There have been some efforts by other people to use these, and I've seen some other custom transformers written. As far as testing them, I mean, I think there is not a particular trick, but I think that at this point, like, we are interested in maybe some more specific feedback about like issues with testing or difficulties in those APIs, where it'd be great to see some comments or JIRAs about things which could be improved.
Okay, thank you.
Sure.
Hi, my question is on Spark on Yarn. So actually, we are trying to build a multi-tenant solution using the Spark. And right now, there is lot of things there in the Spark submit to submit the jobs in the Yarn. But my question is there any short-term, near-term plan where there is a lot of good data integration, but when I need to integrate my job execution and job submission and monitoring and all those things on the Yarn through some third-party web server application or something, is there any plan? Because right now I see the private APIs, but I can't rely on the private APIs because it can change in the future. So basically, I want to submit programmatically job, and then I want to get the status, monitoring, all those things on the Yarn.
Yeah, so by the private API, are you talking about the client?
Yes, we do have the Spark client, a Yarn client on the
sorry,
Spark
I was
client.
referring specifically to the client class. Like, I don't know how far you guys went. But there's a class in the Yarn code, in the Spark on Yarn integration code that's called client. It used to be public. We made it private because it was never really meant to be public. But is there a problem that you've been using that before and then?
Yeah, so right now I see that is the only way through which I can programmatically submit, and that's a private.
Yeah,
so there is a risk that when you make it, like right now, even if it is private, it works.
Right, I can answer like that quickly. So we do intend to offer programmatic submission, not just on Spark on Yarn, but more generally like Spark across like all cluster managers. However, that is, I would say, not really the proper API that we would recommend, just because it's public, but it's not like, it doesn't really offer any backward compatibility guarantees. And the reason for that is because it's never really meant to be public. So in the future, I can't promise when, but there will be a programmatic submission API. In fact, early version of that's already implemented in 1.3, I believe. However, that's so far we've kept it private for various reasons. Maybe Sandy can add something?
Well, so there's Spark 4924, which has this public, like really thin Java API for, sorry, JS, which added this this public, really thin Java API for submitting Spark jobs. Is that marked as private right now?
Sorry, I don't know what Jira you're talking about.
You don't know Spark 4924? There was that Jira which basically added support for programmatic job submission that is originally focused towards Yarn, but not specific to that in any way. Marcelo worked on it. Yeah. Is that currently private?
Yeah, that's currently private.
Ah, okay. I wasn't aware.
Yeah. So we'll introduce a custom way to like launch your applications programmatically in the future, but and it's going to be based on the launcher library that already exists.
So there is nothing in the roadmap like 1.5 or something?
Not currently that I'm aware.
I think it would be good to have it by 1.5. Don't quote me on that. But yeah. I had already sort of assumed that it was there in public, so if it's not, I would be in favor of
I would say
hardening that.
I would say if not 1.5, it will definitely be in 1.6.
Okay,
yeah,
thank
so
you. Because
it is a concern
from the data integration and all other integration point of view, it's excellent. This is the one integration point which is right now painful. Okay, thank you.
This is a question about MLlib. So I guess more of a general design question. Can you talk about the design considerations around parallelizing the optimization step? And I kind of looked at the code, so I was just curious kind of how you arrived at what you did.
Sure. And can I clarify, by parallelizing the optimizations, you mean the optimizations for example, generalized linear models, that kind of optimization?
Yeah, exactly, like
right.
SGD or something like that.
Yeah, so I mean, all of those are really basically distributing gradient computations. And then on top of that, basic operation, you can use like LBFGS or AlQN or whatever. There are, other possibilities for distributing it. You could have data partition, say, by columns. I think that by rows was a natural choice because that is how data tend to be represented using Spark in general. I think for certain algorithms, it would be interesting to try out some other types of partitioning. I think I guess the initial choice was partly because Spark normally operates like that, and because distributed gradient has been sort of like the first step in distributed machine learning, or optimization, which people tend to look at, and fits a lot of use cases where you have, say, more rows than columns. Yeah.
Cool. Thanks.
My other question is about unit testing on the official Jenkins. Do you have any plan to improve running the unit testing on the official Jenkins? As you know, it takes about 1.5 hours to run unit testing on it. It's too long for me.
Yeah, so, okay, so for AmpLab Jenkins, so the long test times are sort of a concern for us too, and there's a few different ways that we're attacking this. For the pull request builder in particular, we're interested in not running every test suite for every commit. For instance, if you look at Spark pull requests, the majority of them now are touching just the higher level libraries, like just Spark SQL or just MLlib and not core. So just a simple optimization, like if you see a change in SQL, only test projects that depend on SQL and not any of its upstream dependencies. That will give a large performance speed up. Other things that we've pursued are maybe parallelizing at the test suite level, so running multiple suites in parallel. So yeah, we have multiple things that we're working on now for that.
Okay, thanks.
My question is on Spark streaming. So we do join of different information streams, and the question is related on back pressure, and on the question, we would not like to use world time just every 2 seconds, but we would like to use the time which is engraved in the data, like the time the event originally took place, to get a more reproducible result from Spark streaming. Is this possible?
So let me get the question right. Are you talking about using event time into to put batches inside Spark streaming?
Yeah.
So that has been an often asked question in Spark streaming, and the problem with that approach is that what the needs of the application is very application dependent. Like different applications would want to deal with delayed records in different manner, etc. So we have been trying to figure out common patterns of how we can deal with this, at least for like 70-80%, or the majority of the use cases that people are seeing. And we are figuring out some common patterns, like introducing something like slack time, etc. And no promises on which version it will come, but it's in my wish list to add a library that supports event time based windowing in Spark streaming.
Oh, thanks.
Yeah, my question is about Spark Circle. So when we want to join a very huge table, right, say like 10 billions, right, is there anything to how to optimize to avoid like a shuffling or something else? And also, is there anything on the roadmap to support like a materialized view on the Spark Circle? Thank you.
Okay, so so when you're doing today, there's no way to hint about the layout of the data on disk to avoid a shuffle. That's something we've talked about doing. The closest thing you can do is if you cache the data. Do we get the partitioning right now? Did we fix that? Oh my God, we gotta fix that. Okay, in Spark 1.5, if you cache the data while it's partitioned, we will remember the partitioning so that we won't reshuffle it again. Because it's like a one-line change, right?
I will remember it will on the next version, right?
Yes. If we don't do that, give us a hard time. Yeah, honestly, we could do that in 1.4.1. If you, is there a JIRA for this? Does Sandy know the number? Do you have it memorized? Okay, maybe even in Spark 1.4.1. We'll try.
How about the materialized viewer?
There are no plans. Well, so what do you want with materialized views? Right? That's a big. If you're okay updating it manually, then yeah, we just do save as table overwrite, and you get a materialized view of your query. If you want like incrementally maintain a materialized views, no, that's hard. That would be a whole different system to do that efficiently. I'm not saying we'll never do it, but I'm saying that's not on the immediate term roadmap.
Okay, thank you very much.
I have a couple of questions. First question is, I just learned that you now support ORC format. So when should we use ORC versus Parquet?
Yeah. Someone want to ask about Scala versus Java again? I don't know. Like,
so basically just test both and see which one works.
Yeah, so once again, I think this is like the same, or Yarn versus Mesos, I think is the other one. My goal in terms of Spark SQL is to support both of them equally. I think they're both accomplishing very similar goals. Today, is predicate pushdown as good in ORC as Parquet? Yes. Oh, okay. So is there? So we have tested ORC less at this point. But other than that, I think really you should look at the data in your ecosystem and choose the format that matches the other tools you're using.
Okay.
Right, I think it has to do with what else you want to use to query the same data. The idea is these formats to be universal, so what that you want to use supports those formats.
Well, my scenario is a lot of columns, a lot of rows, like thousands of columns. I've heard that Parquet is not really good for that.
Any columnar format that does a good job is going to build giant buffers per column. Parquet has a way to avoid doing that. We're not using it today. I doubt that we're doing. Does it work automatically? I think so. You should try ORC.
Oh, so nice. The other question is about reproducibility. So great job on Spark UI. Now it's much easier to understand what's happening. One thing I feel is challenging maybe is if you have, let's say, exception. Let's say some of your nodes has exception or it runs too slow. How do you find out? Is there any plans to have, let's say, okay, I want to reproduce this portion of my job. Let's say I want to download all the input data, download all the jars, everything required, and run it on my machine so I can do profiling and all that.
Look at it, Josh. That sounds like a Josh question.
Yeah, so it sounds like your question was, like, if I'm getting an exception, is there a way to get to a reproduction faster, perhaps? Like
yes, reproduce in this specific portion of job, because let's say my job operates on terabytes of data. I cannot have it on my machine, but for small part.
So I think that there was an old AmpLab project called the Spark Replay Debugger, which actually intended to solve this problem. The idea being that you could sort of replay a portion of the job. And is there anybody that can comment a little bit more on that? Maybe.
I think he has a newer version of that. I remember seeing it.
Yeah, actually, that project was named, I remember it was RDDBG, RDD Debugger. And the original author was Anchor Dave, and later on I rewrote a newer version, but unfortunately it hasn't been merged into Spark, and I don't think it will be. But the good part is that Spark RDD are deterministic, so that we can check and replay any part of the run the tasks and verify the CRC, and so that is a doable approach. But unfortunately, we don't have it right now in Spark. Maybe we can add back the replay debugger later. Yeah.
Okay, thank you.
And again, PR is welcome.
Hi, I was wondering if you can give me some clarity on, I don't know if this is Spark related or MLlib, but I think we're missing somebody. I was expecting to be here, but every time I scale up the problems, they go to the point where they're working, they're very fast, and then hits a memory wall, and then crash, and then never recovers. Are you guys testing to really large size data? I'm talking about stress testing a system. Is this a problem with the core, or is it MLlib that's having these issues? I mean, I'm assuming you're testing for accuracy and getting it correct. I mean, I'm not trying to be rude, but I'm trying to get some clarity on the situation.
Right. So we do both regression testing and attempting to scale out. However, with each release, I do think we focus on regression testing using this library SparkPerf, which covers a number of things like core, streaming, the Python API, MLlib. As far as like pushing it as far as we can go to like larger and larger clusters, larger data sets, there I think we are somewhat limited by the pressures of the release on like, how far we can go up scaling up clusters. It's something which we do try to do to some extent, but yeah, I mean, if there are particular settings which you're hitting, it would be good to hear about.
Is there something that is there something I can change so that it doesn't, it's working, and then it gets to a point where we can't scale up any larger? It's not that it's going to run longer. It's just that all the executors start crashing, and then eventually it all fails.
I see. So, I mean, that could be an adjustment he could.
Yeah. And just for an example, we're talking about like ALS.
Right. This probably isn't MLlib specific, really.
Right. I mean, I think the short answer is there's a million reasons why that could be the case. There are a lot of particular reasons why it might be the case. If you're using Yarn, there's certain parameters you don't tweak. Yarn could be killing your executors.
Pure Spark, just standalone, nothing else.
Spark
Lots and lots
standalone.
of memory, like 256 gigabytes each.
The number one performance tuning tip I always tell people is boost the parallelism. So I don't know if you've tried that yet, but what often happens in these situations when executors are falling over is that the data size increases and each
Many partitions, very, very small.
Many very small
We can
partitions.
shuffle much more, but it'll take longer, it'll fail slower. But still, it gets to that point where it does eventually get to there. So
So I'd say the two obvious things, you probably have neither of them. Best would probably be to post a bunch of details of what you're trying to run on a Spark user thread, and we can rule out the possible causes.
One point I wanted to kind of follow up on. You mentioned, are you running 250 gigabyte heaps for your JVMs, or?
yeah, so we're not, the allocation is at 200. So we have plenty of space for Cloudera and all these other services.
Oh yeah, so one thing I just wanted to comment on. A lot of JVM's garbage collectors tend to perform sort of badly with just gigantic jumbo-sized heaps. So if you have machines that have extreme amounts of memory, like 500 gigabytes per node, my recommendation would be to run multiple Spark JVMs on the same machine, each of a smaller maximum heap. So for instance, if you're running standalone, you could spin up 4 workers, each get them a quarter of the total heap space. This may sort of help to alleviate GC-related pressures that could be causing you to get into like a GC pause and having your app get killed.
And GC is one of the biggest things that we're looking at, but yeah, I'm quite aware.
To add to that, in Spark 1.4, actually, in standalone mode, you're using standalone mode, right? Are you using standalone mode?
Yes, standalone.
Yeah, so if you don't want to start multiple workers, you can even specify you can even launch multiple executors within one worker by a config that I believe is called like spark.deploy.max cores per executor, something like that. So basically allows you to start smaller JVMs to alleviate that problem. Yeah. It's all documented, so you can look it up.
2 questions. One, is there a plan to add general additive models to the MLib? Generalized additive models.
You're saying support generalized linear models?
No,
or
you currently support generalized linear models. There are also generalized additive models for
I
like
see.
splines.
So, for example, some non-parametric models or that kind of thing. Non-parametrics, I think, are a bit esoteric for a lot of people's use cases, but I agree that in some cases they can be really useful and powerful. I have not seen a lot of interest on, say, like, the mailing lists and the like for non-parametrics. But if there is, I think that helps us, and hearing about it helps us in prioritizing. So it'd be good to post about it and see if other people, have use cases where they need it.
Okay, great. The second question is about caching RDDs between asynchronous jobs. Is it possible? Will it be possible? Like if I have many jobs that will use the same data, I want to cache one RDD and use it as an input for those jobs.
Yeah, I mean, I would say, so when you say multiple jobs, do you mean multiple Spark applications? Like, is there a Spark context per job, or multiple jobs that you run against the same Spark context?
It's flexible.
So if it's the latter, which is multiple jobs against a single Spark context, then that's sort of the basic Spark model is that you're allowed to do that. You cache an RDD somewhere in your DAG of operators, and then any actions that make use of the RDD will use the same cache data. If you want to cache data between different Spark applications, so you're tearing down a Spark context and starting a new one, or possibly on a different machine, that's something that Spark doesn't support very well. And so systems like Tachyon are built to do that sort of out-of-application caching and reconstruct lineage in that way.
I just want to make sure when it is the same context, and I may have many threads that do many jobs, it is supported. Okay, thank you.
Yes.
His last question was actually my question, so that's answered.
Okay. I'm sorry, I am asking you again and again. My question is about unitexing in Spark.example. How do we realize ensure Spark.ml's code? I mean, we are trying to deprecate some method in Spark.ml lib. So I think we should go change the example code. How do we ensure the example code?
Let me make sure I understand. It was for the example code, for example, in MLlib. How do we make sure it's valid or runs? I see. Yeah, so this is a case where there's example code and multiple locations. In, for example, the Scala or Python docs, the user guide, and also in the actual examples code folder.
Right.
Examples code folder is quite easy to just go ahead and run. Python docs, easy to do a doc test. I think the challenging ones are, the user guide and the Scala docs. And there, currently, it's essentially tested manually. But we are talking about possible ways of consolidating and improving that to, make sure that, with each release, old code in those docs is not broken.
Okay, thank you.
So it looks like that's the last question, unless someone else. Oh, okay. Go take the microphone. and let's say maybe 2 or 3 more questions, and then we'll call it time.
My question is about Spark SQL and Hive compatibility. And could you just talk about what are the goals for Spark SQL and Hive compatibility as Hive development and continuing like 14 and 1.1, and what are your goals for that level of compatibility? And,
sure.
When would it be important that they're compatible?
Yeah,
not?
totally. So I can talk a little bit, because we actually spent a lot of time in the last release on trying to make this better. So Spark uses Hive in a couple of different ways. Internally, we use Hive for its parser, we use it for its SERDES, we use it for its UDFs, and that's kind of the execution side of things. We also use Hive to talk to a metastore, so to kind of get the information about tables. In Spark 1.4, we drew a line in between these, and they're actually different class loaders running different copies of Hive. And so the reason for this is my goal moving forward is to keep the execution version of Hive as recent as possible. So right now we're on 13, but there's work in progress to bump it up to, I think, 1.2 is the PR that we're working on at the moment. That'll let us give you the most recent version of HiveQL, all of the SerDes, all the most recent UDFs, that kind of stuff. On the client side of things, where we're actually talking to the Metastore, I want to support as many versions as possible. So right now we support 12 and 13. I merged a patch yesterday into master for 14. I think adding 1.0 and 1.1 and 1.2 will be very easy because there weren't many changes to the client. And I'm hoping that somebody submits PRs for versions earlier than 12, because now that's actually not very hard. There's a relatively thin interface there.
Maybe an esoteric question, but if someone was using like post-execution hooks with Hive, is there a way that Spark SQL could be aware of that and respect that configuration?
Nope. Sorry. That's very specific to the internals. We have our own similar types of things. There's like a way to inject things into the planner and stuff, but I don't ever plan to match their API for those hooks.
Thank you.
Yeah, hi. Can you talk about some of the challenges on integrating Spark Streaming and Spark SQL? And if we can expect something anytime soon.
What challenges is a very vague term. Are there any specific challenges that you're interested in looking at being solved? That would be a more directed approach to the question.
Yeah,
yes, please use the mic.
Well, we do have a Spark Streaming application, but we cannot do hand optimization really.
Mm-hmm.
So we want to leverage the optimizations in Spark SQL, which are given, and we would want to be a streaming application still. Plus, window operations, when new data comes in, it's available through the select queries, etc. would be nice.
True. So let me answer this question in two parts. What is available now as of Spark 1.4 and what we may see in the future. So as of Spark 1.4, what you can do is take the D streams of Spark Streaming, get the RDDs from the D stream and convert them to a data frame, and then apply all the data frame SQL operations that you want, convert it back to an RDD and back to RDD D streams and run it. So all your basically business logic, instead of expressing it in terms of D stream and RDDs, you can express it in terms of data frames, and you get all the the optimizations that you get out of data frames. People have done that, and from what I've heard anecdotally, people have seen performance improvements just by converting their RDD D stream operations and expressing them in data frames. So that is something you can do already. Going in the future, we are playing out with ideas like streaming data frames and stuff. There is no promises, nothing, no deadlines, but that is something we definitely would like to spend some dev time on in the future. But again, no promises.
It would be very cool.
It would be very cool. It would be very cool. We could integrate SQL windows with Spark Streaming windows. That there's like bunch of crazy ideas that it would be very, very cool. And some of the ideas that I've been chatting with Cody, for example, is what about a Kafka as a data source with Kafka plus Avro plus JSON as a data source with streaming data frames. Sorry, I went crazy on brainstorming. Yeah.
Thanks for the non-committal answer, but thank you. Thanks for all the great work.
Last question.
Oh, sorry. So I have one more performance memory related question, and I'm almost sure I'm doing something wrong, but I have one very simple play use case for Parquet and data frames, about 10 million rows and about 1,000 columns, and trying to cache. So that's maybe about 2 gigabytes of data in Parquet, but trying to cache that and persist that with either memory only or memory only serialized fills up about 50 gigs of RAM immediately.
Is your data nested?
So no, actually I flattened everything, and first nested, then flattened everything. Still trying to cache that literally destroys the executors immediately. I haven't tried Tachyon yet, but I was interested to see. I was thinking about probably the 16-byte overhead of per object.
So we actually don't have that with the columnar cache.
You don't have that?
But what's missing is the compression inside of the in-memory. So in the in-memory columnar cache, just a little bit of background on how it works, we don't actually keep the objects around. So it is more efficient than if you were doing RDD caching of those rows. We take each column and we serialize it into a byte buffer. We do things like run length encoding and dictionary encoding, but we don't do things like gzip. So that is probably why your data is blowing up and getting significantly larger, because if it doesn't fall into one of the simple compression schemes we have, it's essentially uncompressed. It sounds like you know the answer, though. I would strongly suggest storing Parquet onto Tachyon. Because honestly, we're putting most of our effort in terms of performance into things like ORC and Parquet instead of into this kind of in-memory columnar cache that we inherited from Shark that nobody wants to maintain.
Thank you for the answer.
Cool. So let's have a round of applause for the panelists. Thank you, everybody, for coming. I have just one quick announcement. There is a post-Spark Summit networking event mixer thing going on. It's at 620 Jones. It started at 7 o'clock, so it's going on. If you don't have a badge, you need to talk to Jen in the back, who's holding up tickets, and get a ticket from her, or you will not be able to get in. But we'll be there, so head on over there. Thanks for coming.